Right, guys, this is the last part of 1.12D. I'll make sure to put the other parts in the link in the with a link in the description. And you can download this worksheet as always. Again, the link is in the description, and if you need private tutoring, feel free to reach out. All right, so we're going to start with question number 27. So we are given a figure over here, which is fx with the domain of this and the range of this. Now k is defined as this thing, so we need to find the domain and range of k. Okay, I'm just going to do 27, 28. I'm pretty sure you can handle on your own. So I think I already talked about this earlier, that the domain is affected by all the transformations that are horizontal in nature, and the range is affected by all the transformations that are in vertical world. So here the horizontal world only has one transformation, which is horizontal dilation by a factor of 1 over 2, because it's counterintuitive. So if the original domain was negative 3 to 3, and since the x values are divided by 2, the new domain is going to be negative 3 over 2 to 3 over 2 brackets. And the range, initially it was negative 5 to 3. It is multiplied by negative 3. So if I multiply by negative 3, obviously this will become 15 and this will become negative 9. So I'm going to write this as negative 9 to 15, because obviously the lower number comes on the left side, and then I'm going to go up by 1. So I'm just going to add 1 to these people, so it will become negative 8 to 16. This is going to be my final range for question number 27. Okay, now the function has zeros at negative 2, 0 and 3. Okay, that's an independent question. Then find the zeros of the following function. So remember, the zeros are when the function becomes 0, right? So I'm looking for when is gx equal to 0, or 2 times f of x minus 4 is 0, or f of x minus 4 is 0. And when is the function 0? Because this is as simple as asking that what are the zeros of the function, and it's already given that the zeros are these three values. So I'm going to say that this will happen when x minus 4, because this inside thing is now the new thing, that should be equal to negative 2, so that x should be equal to 2 in this case. That's a new 0. Likewise, x minus 4 should be equal to 0, which will make x as 4. That's another 0. And likewise, x minus 4 should be equal to 3, which means that x should be 7. That's the other 0. Right? In the same fashion, you're going to do this one and this one. I can do another one. I can do C for you. So likewise, I am going to do kx should be equal to 0, which means that negative 5 times f of 3x minus 2 should be 0, which means that f of 3x minus 2 should be 0, dividing both sides by negative 5. And this happens when 3x minus 2 can be negative 2. 3x minus 2 is 0, because after all, these are the zeros, and 3x minus 2 is 3. So from here, negative 2 cancel, so the value of x is 0. That's the first 0. From here, x is 2 over 3. That's the second one. And from here, x is 5 over 3. That's the third one. So these are the zeros of these new functions. Okay, now we're given that new question. Fx has a vertical asymptote at negative 2 and horizontal asymptote at 3. Find the vertical and horizontal asymptote of the function. Okay, it's a good question, but again, the analysis is going to be same, that x equal to something is after all a part of the domain, right? And a part of the domain is affected by all the transformations that are done in horizontal sense, right? So x equal to minus 2, for example, I'm looking for VA, I'm looking for HA. So x equal to minus 2 for this function, as you can see that this is a horizontal translation of 1 unit to the right. So if I move this guy 1 unit to the right, the negative 2 will now become negative 1, and that's going to be my new VA. And the y equal to 2 is the y value. Y is the part of range, and range is affected by all the vertical transformations. As you can see, there are two vertical transformations. One is vertical dilation by a factor of 2. So 3 should be multiplied by 2 so that it becomes 6. And then it goes down by 3 units. So 6 minus 3 is once again 3. Okay, okay, we are just landing at the same position. So x equal to -1 is the new VA and y equal to 3 is the new HA. I hope this makes sense. All right, let's try this one as well. Here, fortunately, again, there is just one horizontal transformation, which is horizontal dilation by a factor of 5 because it's counterintuitive. So I multiply -2 by 5 so to make it -10. So that's my new VA. For HA, first, it is multiplied by negative 3. So the y value is multiplied by -3. So -3 times 3 is -9. And then you add 4 to it. I hope you're able to understand because they are intentionally trying to trick us by writing this in, something that is unconventional. But the way I see this question, I see it like -3 f of x over 5 plus 4. Right? I hope this makes more sense now for the y. So you just multiply -3 with 3 to become -9, and you -9 plus 4 is just -5. So y is equal to -5. That's your new HA. Likewise over here, okay, here you have to be a little careful. Why? Because this guy is not really in a nice form. So I would like to convert this by taking -2 as a factor, because I think I talked about this, that whenever you have a coefficient of x, and especially when you have some other things added or subtracted, it's always a great idea to take that neighbor of x as a factor. First, let's rewrite the question as -2x plus 4 plus 3. And now I'm going to take -2 as a factor. So I'm left with x minus 2 and then plus 3 over here. Okay, so I have 3 transformations now the way I see it. The first transformation is horizontal dilation by a factor of 1/2. So the VA is going to be -2 over 2 for the, because of this 2. So it will become -1. Then I have a reflection about the y-axis. So the sign of x is going to change. So from -1, it's going to become 1. And then it is going eventually to the right by 2. So 1 goes right by 2, so it becomes 3. So x equal to 3 is the new VA. And for HA, that's pretty straightforward. First, it becomes half. So 3 will become 3 over 2. And then you add another 3 to it. So 3 over 2 plus 3 is 3 to 6, 7, 8, 9. Y equal to 9 over 2. That's the HA. It's a pretty good question, like a little different, not the typical boring questions. Okay. This one talks about the graph of the function f is continuous where the limit x approaching to -infinity is given, infinity is given. So we have to find what is the end behavior of these guys. All right. So when you put g as -infinity, in a way you are putting x as -infinity, right? So, and you can clearly see that when x is approaching to -infinity, this thing approaches 4. So it is clear that when I'm putting limit x as approaching to -infinity of -2 f of x plus 7 plus 5, this portion, since it is going to, x is going to -infinity, it is same as going to 4. Because that's not really going to change just because there is a plus 4. Eventually, -infinity plus 4 is still, plus 7 is still -infinity. So this will become 4. 4 times -2 is -8. So -8 plus 5 will be -3 over here. That's the, that's the -infinity part. And when I talk about infinity, limit x approaching infinity of -2 f of x plus 7 plus 5. And when I go to infinity, when this function is going to infinity, you can see that it will behave same as limit x approaching infinity to the function, which is -infinity. So -2 times -infinity is, remember, positive infinity, and positive infinity plus 5 is still positive infinity. So be careful because this negative sign just flips the answer from -infinity to infinity. So be advised. Question number B looks interesting. I'm going to do it for you. X is approaching to -infinity of hx. So x is approaching to -infinity of minus of f of minus x. If it is approaching to negative infinity, remember that when I put negative infinity over here, first off, this negative can just be taken out, right? Don't be confused with this negative. So that just comes out. So this is the question now. Now, when I put x as negative infinity, double negative becomes positive, right? And we can clearly see that when this is negative, so it becomes same as x is approaching to positive infinity, right? And you can see that the positive infinity side is right here. It is going to negative infinity. So this portion approaches to negative infinity because negative of negative infinity is positive infinity, and negative of negative infinity once again becomes positive infinity. It could be a little confusing. I would recommend you to pause this video, think for a while, maybe rewind the video and get the explanation again. But yeah, this is how it works. And for the positive side, x approaching to infinity, minus of f of minus x. This can be written as minus of limit of x approaching infinity to f of minus x. And, uh, and as x approaches to infinity, because of this negative, it is as good as x is approaching to negative infinity, which is 4. So the answer will be not 4, because there is a negative sign sitting outside. It will be negative 4 over here. So that's the answer. Alright guys, I'm going to skip 32 because it is essentially the same thing. You just have to build the function first, the function g, as you can see, that results from the transformation of f, and then use the same concept to move the HA and VA. Just for you guys, I'm going to write how the function g looks like, and then you can do the rest. So you can see that there's a vertical dilation by 3. So it will be 3 times f of x, reflection over the x-axis, so there is a negative sign sitting outside, and then reflection over the y-axis. Okay, well then there is a negative sign sitting with x as well, and then horizontal translation by minus 3. So it will finally be negative 3 f of minus of, going left by 3 would mean that x is replaced by x plus 3. So just be careful to put a parentheses. That's very important. So that's going to be your final function. So just use this and do the transformations. Okay, now they're saying that fx is this, which write an equation of the following functions. There are transformations of fx. Um, well, isn't that pretty straightforward? You just have to plug in the fx and then write the h. For example, I'll do b, so that will be minus 2 of, and just plug in that function, type in that function fx and just do the calculation. So it will be negative 2x squared minus 8x minus 2 plus 2 is 0, which is negative 2x squared minus 8x, right? Over here, you just replace every x by x minus 2. So kx will become x minus 2 square plus 4 times x minus 2 plus 1. So that's going to be, I mean, you can open this up. This will look like x squared minus 4x plus 4. This will be 4x minus 8, and this will be plus 1. So minus 4x plus 4x is gone. 4 plus 1 is 5. 5 minus 8 is negative 3. So x squared minus 3, that's the final function over here. I'm pretty sure you guys can handle these questions. I don't think so there is anything to explain. It's just literally algebra and no pre-cal here. I'll do the function s for you. The function s is going to be negative of every x replaced by x. So make sure to put parentheses, guys, because I've seen students making this mistake. They just write like negative x square and they forget that they have to square the negative. So don't make that mistake. It is negative x whole square, which when squared will become x square minus 4x plus 1, and the negative is going to ram inside. So this is how it is going to look: negative x square plus 4x minus 1. That is the function s. Then we have a couple of more questions. I think that's just a fancy function, but essentially they are doing the same thing. So you just have to, proceed in the similar fashion. This is also a similar thing. So I'm just going to do part C for you, question number 34, part C, where every x is replaced by 4 minus x. So kx will become every x with 4 minus x, right? So be careful. Where we have x at 3 positions, here, here, and here. So 4 minus x, and everything else remains as it is, right? Don't Don't change the other numbers that are written over here. So that's how it looks. 4 minus 1 is 3, so it will be 3 minus x over 6 minus x and then 1 minus x when simplified. So that is our final answer over here. Finally, I'm going to do 35C for you. Again, guys, if you find these videos helpful, if you like the explanation, please like and subscribe, share it with your friends. It will really help my channel because it takes a lot of hard work to build such videos for you. And if you need private tutoring, feel free to reach out. All right, so kx results when a function f has a horizontal dilation by a factor of 3. My recommendation is don't play around with the function directly. Write your answer in terms of f and then do it. For example, if there's a horizontal dilation by a factor of 3, it's going to look like f of x over 3. Then if there is a horizontal translation by 5 units, be careful. Change only x, not x minus 3. If you write it like this is wrong. You just have to change x with x plus 5, y plus 5 because it is going left by 5 and over 3 as it is. And then there is a vertical translation by 2, so you add 2 to it. So this is your final function, and now you can safely plug in these things into this function over here. So this is your new function k of x. So the k of x is going to look like every x is replaced by x plus 5 over 3 minus 3. So this is how this guy looks like, but don't miss this plus 2 because this plus 2 is this portion is just this portion, right? I hope you understand. And this plus 2 will just remain as it is. So finally, our equation will be 2 times x plus 5 over 3 whole square minus 1. If you guys are feeling more motivated, go ahead and open this perfect square and make it a little nicer. But I think I'm happy with this expression. I'm just going to box this up. Well, guys, that's it for this video. I will see you in the next one. If you have any questions, post it down in the comment section. See you. Bye-bye.